We're going to consider how to find various limits as x approaches infinity. As we look at this first one, the first thing that we are going to do is we're going to look at, since we have a rational function, we're going to look at the highest powered term, and it looks like it's an x to the third. So we're going to multiply numerator and denominator by 1 over x to the third. Of course, we can do that because that's equivalent to 1. So let's do that. And if we distribute that to each term, we have 1 over x to the third minus 1 over x over 1 minus 1 over x squared plus 1 over x to the third. Now, using properties of limits, we know that we can look at the limit of each thing in the numerator and in the denominator in each term. So the limit as x goes to infinity of 1 over x to the third, this goes to 0 because we know 1 over x as x approaches infinity and the numerator stays 1, gets smaller and smaller and smaller. And that's also going to be true for 1 over x. The 1's just still here, but these other two go to 0. Now, if this 1 had not been here and we would have been dividing by 0, we would not have been able to do this. We would have needed to come up with some other way. But because the numerator ends up 0 and the denominator ends up 1, our limit ends up 0. Now, looking at this next one, if I wanted to try and directly evaluate, we know e to the 3x. If we think about what e to the x looks like, e to the x looks like this, and e to the 3x would go to infinity even quicker, but e to the negative x looks like this and goes to 0. So it's like which one dominates, which one's going to take over here. So is it infinity or is it 0? So what we're going to do is we are going to actually multiply numerator and denominator by e to the negative 3x, and we'll see why this is going to work nicely. Now we have the limit as x approaches infinity of distributing this. This would give me 1 minus e to the minus 6x over 1 plus e to the minus 6x. And now, as we let x go to infinity, we know that e to the negative x approaches 0, e to the negative 6x just approaches 0 even quicker. So this is going to go to 0, this is also going to go to 0, and our limit then is going to be 1. Now, as we go to look at this next one, we are going to, so that we can evaluate the limit, we are going to multiply numerator and denominator by 1 over x squared. When I do this in the denominator, I'm actually going to put it in a little different form. We know that 1 over the square root of x to the fourth is equivalent to 1 over x squared, but we'll put it like that so that we can multiply this underneath the radical that we have in the denominator. So we have the limit as x approaches infinity, the numerator is 1. The denominator, we've got this radical, and so this is going to become 1 plus 1 over x to the fourth. Now, as x approaches infinity, we can see that this fraction would approach 0, and I'd be left with 1 over the square root of 1, which is 1. So we've got our limit there of 1. Let's look at this last one. We see a rational function again. Looking at numerator and denominator, looks like our highest powered x term is an x squared. So we're going to multiply numerator and denominator by 1 over x squared. And when we do that, we have the limit as x approaches infinity of 3 minus 1 over x minus 2 over x squared, and all of that is over 5 plus 4 over x plus 1 over x squared. Now, as we let x approach infinity, we see that these terms that have our x in the denominator are going to go to 0, and we are left with 3/5. Now, what this essentially means, because x was approaching infinity and we get the limit equals 3/5, then that is letting us know that 3/5 is a horizontal asymptote. And in fact, as we look at the graph here, we see that as we let x approach infinity, there's our horizontal asymptote of 3/5. Now, we didn't look at negative infinity, but we could have done that, And it would not have mattered if we were approaching positive or negative infinity, because if we would have put a negative on this as we work this, these are still going to go to 0 and we're still going to get 3/5. So you can see as we approach negative infinity that it also approaches 3/5.